Alright, so we need to solve for b. We need to find out the measure of each one of these angles and then use a protractor to figure out if our answer is reasonable. So we know here that the sum of the angle measures is 540 degrees. So that means if we add up this angle measure plus this angle measure plus this angle measure plus this angle measure plus this angle measure, it'll add up to 540 degrees. So that would look like like this. Alright, so now we need to try to simplify the left side of this equation. And a good habit to get into is writing like a light line right under the equal sign, just to keep track of where our equal sign is. It helps the brain remember that there's two sides of the equation. So let's see, since these are all just adding, here I got a group that's being added, and I got plus this group plus that. The parentheses can sort of just go away, or you can think about it as distributing a positive 1 through there, which doesn't really change anything. So we can take the parentheses off, which gives us this, and now we can identify our like terms. So anything with a b in it is going to be a like term. So we got 2b and 3 over 2b and b and b. These are all like terms. And it's probably pretty easy to combine these three terms, right? 2b plus b plus another b, that makes a total of 4b. But how are we going to do this guy? Let's just hold on to that guy for a second. Plus 3 over 2b. And let's collect our like terms that don't have a variable, just our constant terms. Here we got negative 90 and a positive 45 and a positive 90. And these are all on the same side, so I can just combine them together. And what's nice is negative 90 and positive 90 add to 0. So they basically cancel each other out. And all we're left with is 45. So plus 45 equals 540. But we still have this fraction problem over here. What can we do about that? Well, allow me to show you a neat trick. The denominator of this fraction is a 2, which means that this 3 is getting divided by 2. So the opposite of dividing by 2 is multiplying by 2, which means that I can undo this fraction by multiplying by 2. But I can't just multiply one thing by 2. I would have to multiply everything by 2, because the multiplication property of equality says you can multiply both sides of an equation by the same number and you get an equivalent equation. But we must exercise caution and remember that it's the whole side of the equation that gets multiplied, which means if you got more than one term on one side, you have to use the distributive property and multiply by each term inside the parentheses that you draw, because you're multiplying 2 by the entire side. Okay, so let's do it. 2 times 4b is 8b. And then 2 times 3 over 2b, well, what happens there, thought bubbles, what happens there is you do 2 times 3 over 2b, and this 2 is like 2 divided by 1. 2 times 3 is 6, and 1 times 2 is 2, so that's 6 over 2b. But 6 divided by 2 is 3, so that's 3b. And I'm so happy because I don't have a fraction anymore. So this becomes plus 3b. Now that was tons of fun, but we can't forget we still have to multiply the 2 times the 45. So we get plus 2 times 45 is 90. And then the easiest one to forget is this sad little guy over here, 540. We got to remember to multiply him by 2. And 540 times 2 is 1,080. So now we have an equation without fractions. Neat. Epic! And now we can continue to simplify the left side of our equation. We have some more like terms right here. 8b plus 3b is 11b. I know sometimes my b's look like 6's, so watch out for that. Plus 90 equals 1,080. And now we're all simplified on the left side. We're all simplified on the right side. So we need to undo some operations here. So we have, here's our variable b. We're multiplied by 11, and we're adding 90. And we undo addition and subtraction before we undo multiplication and division. So let's undo the plus 90 that's hanging around our variable. The opposite of plus 90 is minus 90. So I'm going to subtract 90 from the left side, but that means that I also have to subtract 90 from the right side because of the addition property, or no, the subtraction property of equality, because we are subtracting. So now we have on the left side 11b equals, on the right side, let's see, that's 990. And now our b is only having his style cramped by this multiplication by 11, so let's undo that by dividing by 11. 11 divided by 11 is 1, so we get b equals, let's see, that's going to be 90. So b equals 90. Alright, so what does that mean about this pentagon up here? Well, we can plug in b and figure out what all these guys are. So we know this guy's already 90. We know that this guy now is 90. Let's see, this is going to be 90 plus 45, which is 135 degrees. And then this one is 3 over 2 times 90. So let's see, 3 times 90 is 270. 2 times 1 is 2. And 270 divided by 2 is 135. So this guy is 135 degrees also. Now we just need to make sure that those numbers are reasonable. And here's my reasonability checker. So I have it set on the 90-degree angle here, and it's reading 90 degrees. So I am going to move it to another angle and see what we have there. Oh, I didn't do the math on this one, but 2 times 90 is 180. 180 minus 90 is 90, so this angle is supposed to be 90. Let's see if that's reasonable. 90.8, 90.1, that looks pretty reasonable. Alright, let's check one of these. This one was 135. And, oh my goodness, that's reasonable. Let's check the other one that's supposed to be 135. Let's see if we can get a measurement close to 135. Uh-oh, that looks reasonable. And then the last one, this top guy that we figured was 90 degrees. Let's see if that was reasonable. Reasonable! I hope that helps, and I hope you have a fantastic day. Bye-bye.